All right, guys, here we go. Getting ahead of the game. I'm catching up. So, just to go back to Thursdays, and I'll explain it in class too. That is not. This is homework 5 shouldn't be there. This is homework 4. Homework 5 goes with this bad boy setup right here. So this one's Friday. All right. So we've talked about go back. We got calculator examples. We tackled the calculator examples in class. Use your calculator. Get used to it. Get used to it. Get used to it. I can't tell you how much uh, they'll make the class, much easier when you start learning how to use the calculator. All right, so now we've talked about how we describe these things in words, right? So we describe it with socks, shape, outlier, center, spread, right? So we've just talked about like what these things are. Now, in general terms. Now, what we're going to do is we're going to start attaching vocab to them. Okay. So now all of a sudden we've got with numbers, and when we start describing them, we got to attach vocab to each one now. So we got to attach statistical vocabulary to shape, which we did, our skewed right, skewed left. We've attached the word outliers to it. We still got to do some work with that. We've got to make a center. We got to add some vocabulary to the center. And then our spread, we've got some vocabulary. We did talk about range, but that's a little different. So here's what the deal is. So as we get a list of numbers, we're going to get some terminology. So this is the variables you'll use. This is called X bar. So it's an X with a bar over it. Get it? X bar. And this is a Greek term, mu, like moo, but with a U. So you're going to say moo, but you're going to go mu. So this is a mu, right? So you're like, well, what the heck are these for? So X bar and mu are for the mean. And the mean you guys may know from previous as the word average. We don't use the word average. We use the word mean, okay? So we're going to find the mean. The mean is this. X bar is the mean of the sample. Mu, do it in a different color. Mu, you can write it like that, like an M almost. That's the way I write it. Is the population mean. All right, so what the heck is the difference between the two? Well, what we normally do is, like, let's say we wanted to do, let's just say, I'm going to do this in a different color because I can color code. We're going to talk about average age, right? So if I wanted to find the average age here, I would have to find the mean age, right? I want to find the mean. So here's the difference. Mu goes with the entire population of the USA. So I would have to sample everybody in the United States and measure their height, find out how old they are, and then find the average. So I'd have to do 5 million, what is it, 300 billion people? I don't remember how many people. There's a lot of people in the United States, and I'd have to find the average, which means you add them up and divide, right? That's what the mean is. Now, so, but a sample, I could, let's say, take two samples. I could take a sample of 100 people, two people from each state, let's say, and the sample size is 100. So the sample has 100 people in it. Well, then what I do, it's called an estimator. I use X bar in small samples to estimate what the entire population is. This is cost effective. It's much easier to deal with than trying to find the average age of everybody. It's a lot easier to ask the average age of 100 people and then figuring out if you can extend the data to estimate right? So what we say is X bar is an estimator for mu, okay? So the sample estimates the population. We'll talk a little bit more on that in class. So then we got another vocab word, resistant. So what they ask, is the mean a resistant measure of center? So this is our center. Let me write that here. We're dealing with center on this bad boy. So what is a resistant measure? Meaning, if I add data points, is it going to be very resistant? So if we look at this, and we've got these data points, and we add them all up. So, the old way to do this would be 1, 2, 3, plus 6, plus 8. And since there's 5 numbers, we would divide it by 5. So this would be like 5, 6, 12. This is 20. And so my average would be 4, right? My mean is 4. Now all of a sudden, let's take this. I only got 6 numbers, but now I've got 1 plus 2 plus 3 plus 6 plus 8 plus 500. And now all of a sudden, I don't have 20 anymore, and I'm divided by 6. I have 520 divided by 6. So if I do 520 divided by 6, handy dandy calculator. So your Blues Clues Flans, handy dandy notebook, it's a handy dandy calculator. All of a sudden now my mean of that is 86.6. So the question I have for you is, was it very resistant to this number? If I add one piece of data, or one data point, does it resist change? Okay, so what they mean by resistant, does it resist change? No, it didn't resist change very well. It moves a lot. So mean is not. No, it is not a resistant measure of center. Okay, so how can you estimate the mean? How can you estimate the mean of a histogram or a dot plot? So basically, look, it's like this. If we do just use these numbers and we evenly space them, 1, I got a dot, 2, I got a dot, 3, I got a dot, 4, 5, 6, I got a dot, I got a 3 here, and then 7, 8, I got a dot. Right? So where are we at here? If we kind of look at this, center's right about here. So you can estimate right in there where it's at. So you can estimate the mean by finding the center based on your data points, okay? So it's pretty straightforward, and that's kind of the idea. So if I look at 4, I got 1 away from 0, 2 away from 0, and 3 away from 0. That means I've got a total of 5 units away from 0. If I go this way, I got 2 away from 0, 1, 2, 3, 4. I got 4 away from 0. So that's 6 units. So it's like, if you look at it, I'm looking to the left, I'm looking to the right, it's about the same units away from 0 for all the data points. And we'll get to that measure here soon. So now we're asking about median. Median. So we look at this up here, back up here. I'm kind of back up here. When we're looking at average, or mean is what we call it, we're adding things up and we're dividing by 5. So we're doing a numerical calculation. When we're looking at median, median is the center in the list from least to greatest. Okay? So it's just the center, but it's the center of the list. So if I go like this, and let me look at this here. Let's do the first one. Let's not worry about this. Let's just do 1, 2, 3, 6, and 8. If I look at this bad boy, the center number is 3. So the median, is 3. That is a horrible spelling of median. Sorry about that. The median is 3. My hand's actually cramping. I'm on like my 5th video today. Okay, so now let's look at this. Not a lot of room. If I look at this, let me do a different color. All right, let's see, right there, green. Let's do green. All right, so if I look at this, I got 1, 2, 3, 4, 5, 6 of them. The center of that is right here in between 3 and 6. Well, how the heck do I do that? You just add the 2, 3 plus 6, and you divide by 2. So 3 plus 6 is 9. So my median of this data set is 4.5. Got it? So I got a 5-number set over here. The data set's, the median's 3. I added 500 here. My median's 4.5. It moved just a tiny bit. I'm going to add this number. We're going to add, instead of 500, we're going to add 500 gazillion. I don't even know if that's a gazillion. Guess what? My median doesn't change. It is still 4.5. So now, does median resist change? Yes, absolutely resist change. You can add another data set of like infinity. That's a big number. It's just going to move to 6 because that's the new center. Look, 1, 2, 3, 4, 5, 6, 7 numbers. My center number is 6. So it doesn't change a thing, okay? It moved from 3 to 6, and I added a gazillion, billion, 500, and infinity. Didn't change anything. So median is definitely a resistant measure. Okay, so now, all of a sudden, we've got this. How does that affect shape for the mean and median? Here's the deal. Mean. It only works with symmetrical shapes. So the center of this thing is always X bar. Why? Because if you have a skewed right thing like this, what's going to happen is my median, which I'll do in red, is going to be right about here at the top. That's going to be my median. But my X bar, because I have all these big numbers out here to the right, my X bar is going to slide to the right, which is going to be here. And guess where my median is on the normal one? It's here. So how does it affect the relationship between the mean and median? Mean and median are the same for symmetrical or normal graphs. Symmetrical. The word skewed, this one is skewed right. Looks like my right foot. Pinky toe over here, big toe over here. Why is it called skewed right? Because you've moved the mean to the right. That's how they affect those types of pieces. So range, max, max minus min. So for this one up here, if I used infinity, all of a sudden infinity minus 1 is infinity. Yeah, it's not very good with measuring it. Doesn't work. We don't use this really ever, so what are the two problems with it? It is definitely not resistant to outliers, okay? And it ignores all the values but the minimum and maximum. So you can have data points like this in the middle, and then you can have one way over here and one way over here, and that is how you get the value, and it ignores everything in the middle. So we don't like that. So we don't like that for a measure of spread. All right, so let's talk about quartiles. I'm not going to do a 12.1. I am going to do this one up here, which is 1, 2, 3, 6, and 8. So let's tackle that one. Again, 1, 2, 3, 6, and 8. All right. So how do you find quartiles? So the quartiles are set up as, actually, you know what? I am going to do a bigger one. Sorry, guys. This will be better. Blah, blah, blah here. Let's go back just a little bit. Let me make one up here. Just go 1, 2, 3, 3. You got to duplicate if they're in there. 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 7, 8, 9. Let's do 10. Let's see how we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just go with that. Okay. So if we're looking for quartiles means 25%, right? So this is what we deal with. So I've got, and it's again, quartiles have to do with order. So if they do with order, that means they go with the median. So let's find the median first. Let me do the median in green. I'm going to do the median in green for you guys. So I've got a list of how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means 1, 2, 3, 4, 5. So my median is right in the middle here. So if I take the average of those two, my median is 4.5. So then I'm looking at these numbers on the left here. So I take the numbers on the left and I find the center of that one, which is 3. That is quartile 1 or Q1. I come over here and I look at this list, and there's 5 of them over here. And I look at that one, and that's quartile 3. Okay? That's how you find your quartiles. Now, what happens if we add one more number? Okay, so we've got this one. So you guys can rewrite that one there. And I am going to Control Z until I get them back to here. Okay. Now, I'm going to add just 11 over here. Now, all of a sudden, I've got 11 numbers. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I need to have 5 on this side. I need to have 5 on this side. So now all of a sudden my median is 5. And then I look over here to the left and I got a median number of 1, 2, 3, 4, 5. I got a median of 3. 1, 2, 3, 4, 5. I got a median of, what am I doing here? 8. Okay. So that's, sorry, not a median. This is my Q1, and this is my Q3. Okay? So that's how we tackle those types of problems. All right? So what are we saying? This is what we're saying. We're saying that 25% of the data is here. So this contains 25% of the data. Disregard that. That's useless. All right? This part contains 25% of the data. So the median has 50% to the left and 50% to the right. And then this part here contains 25%. And then this part here contains 25%. Okay? So quartiles just break it up into quarters or 25%. And you got to do it by the list. All right. So interquartile range. Big day today, guys. So interquartile range. Quartiles. Ready? I'm going to do a graph for you on the one above it. I have quartile 1 and quartile 3. The interquartile range is right here in between the two, and it's a measure of spread. It is very resistant. Why? Because it has to do with median. All right? So now, how do I find the IQR? Interquartile range, IQR, is literally Q. Whoa, that's an ugly Q. It's not even a Q. Q3 minus Q1, which for this particular problem here, I would take 8 and subtract it from 3. So that gives me 5. So now here's the deal. If it's interquartile range from Q1 to Q3, what we can say is about 50% of the data is between 3 and 8. That's it. That's what IQR means. All right, let's see what we got. Here we go. All right, coolio. So we're getting crazier, and I didn't know where we're at on the notes. So let's just tackle this one here. Summary of statistics. What I would like to do with you guys is let's just calculate the IQR. You guys calculate the IQR on this one, and you can check with me. But your list of numbers is right here, so remember to count them up, find your Q3 and your Q1, and we'll go from there. Because I think what I want to do is I want to show you how to do it on the calculator, and then we'll do this one in class also. So I think this is what we'll do in class on Friday. Is we'll jump right here, okay? And I'll teach you how to put all those in the calculator. So if you want to do it on the calculator right now, guys, go to page 65. It's not page 65 in the calculator. Holy smokes, page 65 in the book. It tells you how to do it with the calculator. You'll do this with the calculator, and it's awesome. It literally spits everything out for you. You can do it. So I'm going to teach you a lot of calculator tricks in the next couple of days. And then we'll tackle this old school McDonald's menu. Like, I don't even think, let's see, the McChicken, do they even have the McChicken anymore? I got some old data sets, but here we go. We're going to talk about McDonald's chicken sandwiches and talk about outliers, okay? Did I talk about finding outliers? All right, I'm going to give you guys a little formula for the outliers. So to find outliers, I must erase it by accident. So finding outliers, little bonus feature here. Finding outliers. You're going to do your IQR times 1.5, and you're going to add that to Q3, okay? And then your IQR times 1.5, and you're going to subtract that from Q1. And so this will be your lower boundary, and this will be your upper bound. And then an outlier is anything outside. So outlier means it's outside of the boundaries, okay? And I'll do this one in class with you guys, but that's the idea. So we've got a lot of vocab kind of getting slammed in your face right now. So here we go, guys. Good job. We'll see you soon. That's the video. I still got to turn it off. There you go.